When people are first introduced to the possibility of Planet X, they want proof, and not from some wild-eyed lunatic. They want it from a reliable source, and rightfully so. To demonstrate this proof, we first need to understand how astronomers actually discovered the outer planets in our solar system. The search for Planet X actually began when early astronomers first observed perturbations in the orbit of Saturn. Through mathematics, they predicted the existence of Saturn's perturber. William Herschel, a German-born British astronomer, then used this mathematical prediction to discover the planet Uranus in 1781. Interestingly enough, astronomers soon found perturbations in the orbit of Uranus as well. Based on the perturbations observed in the orbit of Uranus, a brilliant young 19th century British mathematician and astronomer by the name of John Couch Adams mathematically predicted the existence and position of a massive object in the outer solar system, one he believed was large enough to be Uranus's perturber. Then German astronomer John Gall used Adams' mathematical prediction to discover the planet Neptune in 1846, and as with Uranus, astronomers would then find perturbations in the orbit of Neptune as well. Consequently, the search for Planet X was far from over. When Clyde Tombaugh discovered the planet Pluto in 1930, many jumped to the conclusion that it was the mysterious Planet X that everyone had been looking for so long. However, when the mathematicians began running the numbers, it became quickly obvious that Pluto had nowhere near the mass to be Neptune's perturber. When you compare Pluto with the Earth, the math becomes self-evident. Here you see Pluto and the Earth. Pluto seems tiny because it is tiny. In fact, it's roughly 60% the size of our own moon. This is why Pluto was recently demoted to the status of a dwarf planet. Oh well, fame is fleeting, so let's refocus our attention on the critical point, which is the ongoing search for this elusive Planet X. In the spirit of Herschel, Adams, Gall, and Tombaugh, the National Aeronautics and Space Administration, NASA, continued the search for Planet X, and in 1992 they issued a landmark press release. It said, "Unexplained deviations in the orbits of Uranus and Neptune point to a large outer solar system body of 4 to 8 Earth masses on a highly tilted orbit beyond 7 billion miles from the Sun." After this announcement, the whole topic of Planet X mysteriously disappeared from the media spotlight. And this takes us back to the 1984 U.S. News article stating that NASA's Infrared Astronomical Satellite, IRAS, detected an object of intense speculation in 1983. Could this be the same object they reported in 1992 as being 7 billion miles from the Sun and as massive as 8 Earths? Given NASA's silence on the matter, who is to say? But then again, this silence does beg the question, what did they see and what did it look like? Perhaps a good guess starts with the IRAS itself. When we use amateur telescopes and binoculars in our backyards to view the heavens, we're looking at the skies in the visible light spectrums. However, as the name implies, the Infrared Astronomical Satellite, or IRAS for short, was used to view the heavens in the infrared spectrum. Our military and paramilitary forces use infrared devices for surveillance and to target the bad guys at night. This is because infrared devices show us the heat signatures of objects, such as the engine in this jet fighter. Likewise, astronomers use infrared telescopes to penetrate the dusty regions of space where it is difficult for us to observe cool, distant objects. With this in mind, Let's assume that IRAS imaged Planet X in 1983. If so, what might it have looked like? Assuming it was spotted, it may have appeared like this, a faint reddish object. So what could that be? In 1984, astronomers felt it could be one of two things: a massive protoplanet forming at the edge of our solar system, or a brown dwarf companion to our own Sun. While a protoplanet would obviously lack the mass to perturb the orbits of Uranus and Neptune, a brown dwarf certainly would. So then what is a brown dwarf? In simple terms, a brown dwarf is an unborn star, and astronomers have recently learned that these unborn stars are the most common type in our galaxy. Unlike our Sun, which has the necessary mass to keep its own nuclear furnace burning, brown dwarfs lack the mass needed to stay lit. Consequently, they ignite much like our own Sun did, then sputter out and slowly die like the hot embers of a campfire. This is one reason why brown dwarfs are difficult to view in the visible light spectrums, because they're shrouded by a large ball of dust created by their initial ignition. However, a brown dwarf would stand out to the IRAS like a sore thumb due to its heat bloom. That's why infrared telescopes are